morning, children. Welcome back to your chemistry class. We had started with the chemical reaction chapter and we have finished with the first three, that is your combination reaction, decomposition reaction and simple displacement reactions. I hope you have even learnt all your reactions. Today we shall begin with the double decomposition reactions. So let us understand what is double decomposition reactions. Over here, two compounds, that is AB and CD. Okay, here what happens, mutual exchange of radical takes place. Now let me make you understand what do I mean by mutual exchange. This is a compound, okay, it is made up of a positive and a negative ion. This is also another compound made up of a positive and a negative ion. So the positive ion of the first compound combines with the negative ion of the second compound. So it forms a new product that is called as AD, which is a new compound containing a positive ion A plus and a negative ion D minus. Okay, and what? C and B combines. C and B combines over here to give you another compound. What is this? C is plus and B is minus. So what has happened? Just mutual exchange of radicals have taken place to give us a new product. This kind of a reaction is called as double decomposition reactions, right? These double decomposition reactions are of two types. What are they? They are precipitation reactions and neutralization reaction. Okay, so we are going to study about all these types of reactions. So let us begin with the precipitation reaction. Precipitation reactions. Now, what are precipitates? These are insoluble products, also written as PPT, mentioned as PPT, and they are denoted by a downward arrow. They are colored, they could be colored, they could be colorless, but they are insoluble products. What are they? They are insoluble products. So let us look at some of the reactions over here. Like for example, carbon dioxide, when it reacts with calcium hydroxide, okay, it gives us calcium carbonate plus water. So what is this? This is your PPT that is formed. This is your insoluble product that is formed over here. Another example could be NaCl when treated with AgNO3. It is going to form white curdy PPT. What is this? This is a white curdy PPT of silver chloride and colorless NaNO3 is formed over here. Fine. Some more example could be like your barium nitrate. It can combine with K2SO4 and it's going to give you white PPT of BaSO4, which I'm going to mention like this, plus KNO3 will be formed over here. So till now I was talking about white PPTs. Now let me talk about some colored PPTs. For example, FeCl3 when treated with NaOH, right? What is it going to form? It will form FeOH whole thrice plus NaCl. Now this is your reddish brown PPT. Okay. Another example could be like copper sulfate when treated with NaOH. It is going to give you CuOH whole twice. This is a pale blue PPT and Na2SO4 colorless solution will be formed. Fine. So these are some of the PPTs. Now you must be wondering, Miss, how to learn these PPTs? So always remember the compounds of sodium, potassium and ammonium, they never form any kind of a PPT. Never form any PPT. Okay, this is something that you have to remember. See, that is why I took sodium over here. I could have taken KOH over here. I could have taken NH4OH over here. So their compounds, they never form any kind of PPT. Whereas all other OH groups, hydroxides, they all form PPTs. They could be white or any colored. This you will have to learn, which I am going to send you in the next video, your reactions along with the colored PPTs. Is this very clear to all of you? Next, let us talk about neutralization reaction. Talking about now neutralization reaction. As the word suggests, neutralize. Neutralize means to neutralize the effect. So over here, when acids, they combine with bases, they always form salt and water. So if salt along with water is formed, then it is a neutralization reaction. In the precipitation reaction, what did I tell you? The PPT was formed over there. So since PPT was formed, no water was formed there. Hence, they were precipitation reaction, except for the first reaction that I wrote over there. That was carbon dioxide was when treated with the lime water, that is CaOH whole twice. But there, that was a precipitation reaction. Why? Because precipitate was formed. So emphasis is given more to the precipitate rather than to the water. Therefore, that reaction comes under precipitation reaction. Whereas others where simple salt is formed along with water, they are termed as neutralization reaction. So let us look at some of the reactions over here. Acid, for example, HCl. If I treat with the base could be like NaOH. So it is going to form a salt. What salt is it going to form? It will form NaCl plus H2O. Okay, so this is your neutralization reaction. That is, acid is neutralizing the effect of the base and base is neutralizing the effect of the acid. Therefore, since they neutralize the effect of each other, that is called as neutralization reaction, forming salt and water. Let's take some more examples like BaOH whole twice plus H2SO4. What is this going to form? It will form BaSO4 plus H2O. So water along with the salt is formed over here. Then say ZNO. These were the hydroxides. They are also bases. Oxides are also bases. Do remember, when I treat it with H2SO4, it will form what? ZnSO4 plus H2O will be formed. Correct? Then let's talk about calcium hydroxide. When treated with HNO3, this can form CaNO3 whole twice. This is your salt and water is formed. So everywhere you will find salt and water forming. So such kind of reactions where there is no PPT formation but a salt and water is formed, then such reactions are termed as neutralization reaction. Clear? Let us talk about some of the neutralization reactions which happen in our day-to-day life. For example, the first one could be your acid rain. What is your acid rain? When carbon dioxide gases, sulfur dioxide gases from the industries and all, they evaporate, they move into the air and they come down with the help of the rain. That is called as acid rain. So what do these acid rains do? They spoil the crops, right? So to protect the crops, the farmers, they spill CaOH whole twice, that is the slake lime. And thus, what is acid rain? It is acidic in nature. What is CaOH whole twice? It is basic in nature. Thus, this CaOH neutralizes the effect of the acid rain and protects the crops. Okay, this was one of the example. Another example could be when you are bitten by a bee. So what does the sting of the bee have? It has formic acid, that is HCOOH. So what do you do when you are bitten by the bee? You rub the key or you can even rub the CaOH whole twice, that is in Hindi called as chuna. So what are all these things? The iron which you rub, the key that you rub, when it combines in the presence of the air, it is also forming a hydroxide which is a base. So when you rub this base over your sting of the bee, what happens? It neutralizes the acidic nature of that formic acid and helps in preventing the pain or gives relief to your pain. Another example could be when you rub the sting of the bee with the soap. So soap is also highly basic in nature. That is also going to help you give you relief from the pain. Okay, another example could be the antacids. So the acidic problem, number of times what happens when you don't eat anything. So the HCl that is continuously released in our stomach to digest the food, right? And when you don't eat anything, it increases your acidity. So how to curb this acidity? It is highly painful. So how to curb this acidity? By using antacids. What could be that antacids? Like milk of magnesia. What is the formula for milk of magnesia? It is MgOH whole twice. This is prescribed by the doctors, right? This is called as milk of magnesia. Another Another example could be like taking enos. They also are basic in nature. They help to neutralize the acidic problem of your stomach. Then a very good base that could be used in acidity is your cold milk. Cold milk is highly basic in nature. That is equally helpful. But yes, cold drinks are not helpful. Do remember, because cold drinks, they contain acidic gas. What is that acidic gas? Carbon dioxide. So that does not give relief to your acidity. But these kind of substances like your milk of magnesia, eno, or even cold milk, they are helpful in curbing down the acidity in your stomach. So these were some of the examples of your neutralization reaction that happen in a day-to-day life. Let us now come to exothermic and endothermic reactions. Endothermic reactions. Okay. So what are exo and endothermic reactions? Now let us talk about exothermic reactions. Exothermic reactions are those reactions in which the heat is given out. The reactions in which the heat is released. Exit, released, given out. Also mentioned in the reactions as plus, and a triangle is made. Plus means heat is given out and the triangle is the sign of the heat. So let us talk about some of the examples over here. Like for example, calcium oxide, CaO, right? When it is placed in a beaker containing some water, so what will happen? Lot of heat is given out. Hissing sound is produced, right? And forms calcium hydroxide. What does it form? Calcium hydroxide is formed. So how am I going to write over here to show exothermic reaction? I'll write here plus delta. So when you see plus delta or plus triangle sign, it is always an exothermic reaction. Let's talk about one more example like magnesium. When it is burnt in the presence of oxygen, it forms magnesium oxide and also lot of heat is released. So such reactions where heat is given out from the system of the reaction, then they are termed as exothermic reactions. There are some reactions or some changes where the energy is absorbed, means lot of energy has to be given to the reaction for the reaction to proceed and give us the product. Such kind of reactions are called as endothermic reactions, where heat is utilized or absorbed for the reaction to proceed. Such kind of reactions are endothermic reaction. For example, like NaHCO3. Now over here it has to be heated. So the heat is given, endothermic reaction to form Na2CO3 plus H2O plus CO2. So this reaction cannot take place till I am not going to heat this compound, and therefore this is your endothermic reaction. Another example could be if I take coke which is red hot. Imagine it is red hot. So firstly I am heating this coke, I am giving it energy. Then I am using water in the form of a steam. Again I am giving it lot of energy to convert this water into steam. Remember, so lot of energy has been given for the reaction to proceed, but the reaction does not proceed. Still it needs 1000°C heating. After all this input of energy, it still needs more input of energy. So all this is your absorption of energy for the reaction to proceed, and thus it gives us what? This is called as water gas. Okay. So these are some of the endothermic reactions. I hope this is very clear. Oxides are of 4 types. What are those 4 types of oxides? Oxides, they are of 4 types. What are they? They are your acidic oxides. Okay. Then they are basic oxides. Then we are going to study about amphoteric oxides, and lastly your neutral oxides. So in this video we are going to talk about all these different types of oxides. Okay, so let us begin with the acidic oxides. What are acidic oxides? When non-metals combine with oxygen, they form non-metallic oxides, and non-metallic oxides are termed as your acidic oxides. Non-metallic oxides, okay, they are termed as acidic oxides. For example, carbon when combines with oxygen will form carbon dioxide. Sulfur when combines with oxygen forms sulfur dioxide. Okay, then phosphorus combines with oxygen, forms phosphorus pentoxide. So what are these? These are all your non-metallic oxides, which are also called as acidic oxides. These acidic oxides, they easily dissolve in water to form their respective acids. Like for example, CO2 plus H2O forms H2CO3. Similarly, SO2 plus H2O will form sulfurous acid. Then P2O5 plus H2O, it forms H3PO4. So they are all what? They are all acids. Hence, what did we study in acidic oxides? Acidic oxides, they are also termed as non-metallic oxides. These are non-metallic. When non-metals combine with oxygen, they are called as non-metallic oxides. These non-metallic oxides, they are also called as acid anhydrides. Okay, why are they called as acid anhydrides? Because look here, when they dissolve in water, they form their respective acids. Now anhydride means removal of water. So from these acids, like for example H2CO3, from this acid, if I remove water from here. So when you remove water, what am I going to do? I will remove H2, okay, and one oxygen, CO2. So what is left? CO2. So this is called as acid anhydride. So what is the acid anhydride used in carbonic acid? CO2. What is the acid anhydride used in sulfurous acid? SO2. What is the acid anhydride used in phosphoric acid? P2O5. So the non-metallic oxides, they are also called as acidic oxides, also called as acid anhydrides. How do we test for these acidic oxides or non-metallic oxides or acid anhydrides? Yes, the test is that they turn blue litmus blue, litmus, red, right? Acid anhydrides or acidic oxides, they turn blue, litmus, red. Now let's talk about basic oxides. Basic oxides, what are basic oxides? They are metallic oxides. Metallic oxides. Okay. Now let's see Na plus O2. That is, metals when combined with oxygen, the oxide that they form is called as metallic oxide or basic oxide. Similarly, calcium when combines with oxygen will form calcium oxide. Magnesium when combines with oxygen forms magnesium oxide. So, what are these? These are all metallic oxides which are also basic oxides. These basic oxides also dissolve in water. So, the basic oxides that dissolve in water, what do they form? They form alkalis. That is NaOH. So, OH groups, what are they called as? Alkalis. Similarly, CaO when dissolved in water, it is formed CaOH whole twice. Similarly, MgO when combines with water, it will dissolve to form MgOH whole twice. So, what are all these? These are all your alkalis. So, what are alkalis then? Alkalis are those hydroxide compounds where the metallic oxides or basic oxides, they dissolve in water to form the hydroxides. They are called as alkalis. These alkalis, they are also bases, right? They are basic in nature. They are also termed as bases. But remember, all alkalis are bases, but all bases are not alkalis. See, over here they are also base. They are also basic in nature, right? Then what is the difference between basic oxides and alkalis? Basic oxides are those where metals react with oxygen to form metallic oxide. They are your basic oxides or metallic oxides. Those metallic oxides or basic oxides which dissolve in water, they are alkalis. They are also basic in nature. Clear? But all alkalis, we have to remember, are bases, but all bases are not alkalis. This is a punchline that you should remember. I'm writing it down over here, that all alkalis are bases, means these are all bases, but all bases are not alkalis, right? So let us look at some of the example. This one is very clear. All alkalis are bases. All alkalis, they are also bases. They are also basic in nature. They are also basic in nature. Now, but all bases are not alkalis. So let us look at some of the examples. Like copper oxide. This is basic in nature. Copper combining with oxygen to form copper oxide. But this does not dissolve in water. Okay, and it does not give us CuOH whole twice over here. So this is not your alkali. This is not your alkali. Clear? This is basic in nature, right? But it is cannot be called as an alkali. Similarly, Fe2O3 when dissolved in water, it will not form FeOH whole thrice, and therefore this is also not your alkali. They are all basic in nature, but you cannot call them alkalis. Is that clear? These are few of the exceptions that you have to remember. How and why? That is no reason to be told over here. You just have to learn this by heart, that all alkalis are bases. Here you can give some examples like Na2O, CaO. They are bases. They dissolve in water. They give us alkalis. But all bases, for example CuO, Fe2O3, they do not dissolve in water to give us those hydroxides. Therefore they are not alkalis. Yes, they are basic in nature, but they are not alkalis. I hope these two oxides are very clear to you. We now come to amphoteric oxides. Coming to the third kind of oxide, that is amphoteric oxides. Now what do we mean by amphoteric? Amphoteric are those metals, amphoteric metals first you should know. Amphoteric metals are like for example your aluminium, zinc and lead. These are the only three metals that you have to learn in this amphoteric as an amphoteric metals, right? Now what are amphoteric metals? Amphoteric word means that these metals, they exhibit both acidic and basic nature. When I say they exhibit both acidic and basic nature, I mean to say that they react with both acid as well as bases to form oxides. Thus they are called as amphoteric oxides. So let us talk about aluminium. Aluminium can combine with oxygen to form Al2O3. So this is neither your acidic nor basic, right? What it is? It is an amphoteric oxide. I hope this is very clear to you. Then another example, zinc combines with oxygen to form what? Zinc oxide. This is your amphoteric oxide. Then lead combines with oxygen to form PbO. So what are these? These are your amphoteric oxides. Followed? Now, as I said, these amphoteric oxides, they exhibit both acidic and basic nature. Acidic and basic nature meaning to say that they react with both acid as well as bases. So let us look at some of the reactions of this. Like I'm going to pick up the first one. Look over here, aluminium oxide. This can be treated with HCl with an acid, and what is it going to form? It will form AlCl3 plus H2O. Okay, so this aluminium oxide, which is amphoteric oxide, reacts with an acid to form a simple salt and water. Now this same amphoteric oxide can also react with concentrated hot alkalis, that is for example NaOH, and it forms a complex salt over here. What is the name of the complex salt? It is called as sodium metaaluminate. Okay, what is the name of this? Sodium metaaluminate. Okay, plus water. Since oxide is there, hydrogen is there, therefore water will be formed. But with the acids, they form simple salts. With the hydroxides or with the alkalis or with the strong alkalis, they form a complex salt. So this was an example with aluminium forming aluminium oxide and aluminium oxide showing its amphoteric nature, that is both reacting with acid and a base. Now let's talk about zinc. Zinc oxide can be treated with HCl with the acid to form what? ZnCl2, which is a simple salt, and water is formed. Similarly, ZnO can also react with hot concentrated alkali, and it will form again a complex salt. What is that complex salt? Sodium zincate. What is the name of this? Sodium zincate, and water will be formed. So over here you can see this is an amphoteric oxide which is reacting with both an acid and a base. Then another example with PbO. So let us look at PbO. It can also combine with, I'll take H2SO4 over here now. Change the acid. So what are we going to get? We will get PbSO4, a simple salt, and water is formed. Okay. This same PbO can also combine with a strong alkali, KOH. I've changed the alkali over here also. Two strong alkalis are there. What are they? KOH and NaOH. Otherwise, calcium hydroxide, magnesium hydroxide, they are weak bases. So they are not going to react with the weak bases, but they are going to react with the strong bases only. So either you take KOH or you take NaOH, right? So over here, it is going to give you a complex salt. What is that complex salt? K2PbO2. What is the name of this? This is potassium plumbate. potassium plumbate plus water is given out. It can also be treated with NaOH, right? And it can form Na2PbO2 plus H2O. What is the name of this? Sodium plumbate. Now it will be called as sodium plumbate. So these are some of the amphoteric oxides that you have to remember. Now what is amphoteric meaning? Exhibiting both acidic as well as basic nature. That is, they can react with both acids as well as bases. So this was your amphoteric oxides. Last but not the least, we come to the fourth kind of oxide, that is your neutral oxide. Now why are they called as neutral oxides? Because they are neutral towards litmus. Okay, therefore they are termed as neutral oxides. They show no change in the color of the litmus. Like for example, the acidic oxides, they turned blue litmus red. Basic oxides, they turned red litmus blue. Amphoteric, they are treated with both acid and bases, so they do not show any change over here. But yes, their property, their salt formation is different, therefore they show amphoteric oxide formation. The neutral oxides, they show no change in the litmus test, and therefore they are neutral and called as neutral oxides. So what are the examples that you should learn over here? Like hydrogen will combine, like hydrogen will combine with oxygen to form water. So water is your neutral oxide. Similarly, nitrogen will combine with oxygen to form nitric oxide. This is also neutral. So these two oxides, they are neutral oxides. Even your carbon, when combines with oxygen, forming carbon monoxide. Carbon monoxide is also your neutral oxide, but carbon dioxide is your acidic oxide. This is the difference between the two. We finish off with the chapter. Revise everything properly. If you do not understand anything, you are free to ask me, and learn all the reactions well. Thank you.